information. So today we'll illustrate one example how to fit a straight line of a two variable linear model. Suppose y is the function of x, so y is a dependent variable and x is an independent variable, and y is supply of a commodity. Suppose y is supply is a commodity and x is market price. So their relationship is the supply of the commodity depends on the market price. So we observe in the market that when market price increases, this leads to an increase in supply. This is a common character in the market, that when price is high, supply will also be higher. People will, producers, they will bring more of the commodities to the market and vice versa. So if we put the points, that means the pairs, suppose x1 is this much, y1 is this much, then x2 is this much, y2 is this much, and so on, up to n number of observations. Then if we put it in the scatter, so this will indicate what will be the nature of the function, whether it will be a straight line. If the scatter is in the form of a straight line, then it indicates that there will be a linear relationship between y and x. And if the scatter is, say, curve, upward rising, downward dropping, similarly, so there will be quadratic or nonlinear functions. Okay. Now the observed data may vary, because when we feed the function, there will be error. Why error? That observed data may vary due to omission of variables. Variables may be omitted. Some important variables may be omitted. Then random behavior of human. See, human behavior is random and response may not be so good. Then imperfect specification of the model. Then aggregation error. So when we will aggregate, there will be error. Then errors of measurement. And so within these limitations, we will have to fit the functions. That's why we will have to assume some assumptions. We will take some assumptions that we have already discussed in the theory. What are the assumptions of linear models? Suppose the estimated function is yi estimated is equal to alpha estimated plus beta estimated xi plus ui. Ui is the error. And it is a straight line. Suppose it is a straight line based on the scatter. So first we will have to put the scatter. So scatter indicates that the a straight line will be best fitted. Okay. So two normal equations are summation. So we have already got it earlier that how two normal equations are developed. So two normal equations with minimization of sum of the squares of the error term. Sum of the squares of the error term. So ei is nothing but yi minus estimated y. So the difference between estimated y and, suppose first observation y1 and estimated y1. What is the difference? This will be e1. So there will be n number of e, and we have already discussed that sum of the square of the error term should be the minimum. And based on this, we developed two normal equations. Now, to fit this two normal equations. In two ways we can fit. One is deviation form, and another is the summation form of without deviations. We can do that. So without deviations, so if we are to find out estimated alpha, necessarily we have to eliminate this. Beta head, this is summation, it is omitted. Beta head summation xi yi is equal to alpha head summation xi plus beta head summation xi squared. So we'll put summation here, and so need to hurry. Okay, and so we'll have to eliminate b. So how to eliminate that? This must be multiplied by summation xi squared. Okay, and this equation must be multiplied by summation xi. Then subtract like that. So we will get after simplification, transfer right side, left side. So after simplification, we'll get the alpha estimated. Then similarly, we can put the value of alpha estimated in any one of the equations. We can get, or we can eliminate alpha and get the value of beta. So, and put the value of beta here, and we get alpha like that. Or if we find out the deviation form, so deviation form will be, so ultimately alpha head will be beta bar minus beta head x bar. Beta head x bar. So this is the average and this is the average. And this is for students of economics, this will be easier to understand or easier to remember. Okay. So the students of pure maths, they may go little differently, but we can remember this. And beta head, after deviation, deviate from mean and find out x into y and sum up. X into y and sum up, and summation x squared. It is deviated x. That means x minus x bar. So x1 minus x bar, x2 minus x bar, and so on. And similarly y1 minus y bar, y2 minus y bar, and so on, like this. Then similarly x squared. So if we find out this, summation xy divided by summation x squared is the beta head. So this, I think this will be more easier to remember. Okay. Now one example with data. Suppose data are given. So yi is the quantity in tons, and xi is the market price per ton. Okay. And there are n number of observations or n number of pairs. So when market price is this much, the quantity supply is this much. So the market price is this much, quantity supply is this much, and so on. When market price is this much, quantity supply in the market is this much. Now this is the data available. So from here we can find out. So if we put it in the Excel, in the computer Excel, automatically you can find out these things with command. So summation y, if we add summation y is equal to 756, summation xi, if we add this series, it is 108, summation xi square is equal to 1020, and summation xi yi, this is non-deviated, that is 6960, and this is deviated, summation y is equal to 0. Sum of the sum of the data with mean deviation is always 0. Then sum of mean deviated x is 0. So minus and plus will be same. Ultimately, summation is 0. Then y bar, that means the average of y. That means sum y divided by 12, and number of observations are 12. So y bar is equal to this, x bar is equal to 9, and summation xi yi, that means deviated x, deviated y, multiply, sum up 156. Then sum of the square of the deviated term is 48. So estimated, we have seen that estimated y bar is equal to 756, and estimated EI is 0. EI is 0, and so in this, so if we find out the EI for 12 observations, E1, E2, so on, this Y1 minus Y1 estimated. Now, estimated Y is this much, and you divide this. You subtract estimated Y from the original level of Y, and we will get E1 like that. We will get E1, E2, so on up to E12, and sum of this is this much. So alpha head, estimated alpha is equal to, as I said, remember this, y bar minus beta head x bar is equal to, if we estimate and simplify, it is 33.75, and beta head is equal to summation xy by summation x squared. This much is equal to 3.25. So estimated line is just alpha 33.75 plus 3.25 xi. This is the beta values. So it is a straight line, it is a positive. It is a straight line which is upward rising. It is plus, so it is a straight line rising up. Okay. Now we can see this in the graph. So let us see the graph. So if we feed the least square line, it will look like this. So in the vertical axis, we have the supply in tons. So one division, say 10 units. And towards horizontal axis, it is the market price. So when market price increases, or supply of the commodity also increases. Now, we have seen that estimated line is 33.75 plus 3.25 xi, when 33.75, it is the intercept. Okay, intercept from 0 to this much, 33.75. So this is the intercept, the value of alpha. and after this the curve rises at the rate of 3.25. So this is the rate of change, or we call this a tendency. So at this, we have seen that it is the value of the tan theta, 3.25, approximately is a 3.27. It is a tan theta. When theta value is this much, we can see from tan table that when theta value is this much, degree is 72.70, say approximately. Not so accurate, 100%, approximately this much, just for demonstration. So 72 degrees, so we'll have to draw a 72-degree angle here and expand it. Then this line is the estimated line, and we assume that it is the most desired or best linear estimated line satisfying the assumptions, and it will divide the scatter into two equal halves. So based on the scatter, because if you see the scatter, so market prices are low, that's why the curve is started from here. So it is a second. So this is the line, estimated value below 33.75 plus 3.25 xi. This is the fitted line. So this way we can fit a straight line, and if the specification is different, say quadratic or a declining straight line, then accordingly we'll have to estimate the parameters from the two normal equations. So you can do some more exercises, and this is the demonstration. So with this we have concluded the two linear model, two variable linear model, and we will go some other topics like properties of estimates, etc. So thank you very much, and thank you for watching. Go on watching and subscribe and share. Thank you.